Python programming, data analysis, visualization, and the fundamentals of machine learning. Today, we move into one of the most rapidly evolving areas of technology: artificial intelligence, applications, and generative AI. Today's session will introduce generative AI, large language models, and the fundamentals of prompt engineering. We will also explore how AI coding systems can enhance Python programming by supporting tasks such as data cleaning, data analysis, report writing, visualization, and documentation. In addition, the session will highlight the importance of ethics in AI, responsible AI, and the future direction of intelligent systems. To reinforce these concepts, we will engage in hands-on activities involving AI-assisted Python programming, AI-powered data analysis, and prompt design exercises. Generative AI is transforming the way we learn, write code, analyze code, and solve complex problems. Understanding how to work efficiently with AI tools and how to use them responsibly is becoming an essential skill for every student, researcher, developer, and data professional. Today's session will provide practical insights into integrating AI into everyday workflows while emphasizing ethical and responsible use. I encourage everyone to actively participate, experiment with the AI tools demonstrated during the session, and engage in the hands-on exercises. The more you practice writing efficient prompts and collaborating with AI, the better you will understand its capabilities and limitations. It is now my pleasure to welcome our esteemed mentor and speaker, Dr. Meher Chand, whose expertise in AI, machine learning, data science, and Python programming continues to inspire learners through his practical, research-driven, and industry-oriented approach to teaching. With great pleasure, I invite Dr. Mehchan to kindly lead us into today's session. Over to you, sir.
Okay, dear friends, thank you for the nice introduction. And dear participants, good evening, all of you. And I hope that all of you are doing well. So yesterday we present some important content, and I hope that you try to understand the concept. And today we will implement all those things practically. How these things will work, how you can implement. Okay, so there are two parts. First, I want to present here a very simple example. My screen is visible? Not yet, right? Okay. So now I think my screen is visible. Okay, so here still the participant, good evening, good evening. Okay. So here we have very small data set, and just to clear the concept which we are required. Toggle. Okay. So in the previous session, which we have completed, we have some objective of the feature scaling, coding, data preparation for the machine learning. Okay, and before that, applying this method, we are required data pre-processing, data cleaning. Okay, understand the data set by using different type of the techniques, everything, many things we are required. And then after we have this technique, which you can see here, feature scaling, encoding, data pre-processing for machine learning. Okay, so objective is clear healthcare data, handle the missing values, encoding categorical examples, scale numerical features, perform feature engineering, and pre-processing pipeline. So some of the participants were asking about the feature engineering. Here is the concept we have discussed yesterday, but here we are using some Python concept. Okay. So that when you will implement for any machine learning model, you can easily do. Here we have the data set which you can see here, sample healthcare data set, very small data you can see. And in the first column, we have the patient ID, then we have age, gender, blood pressure, cholesterol, BMI, body mass index, smoking, diabetes, disease. Okay, in this column, age, you can see one value is nan. Nan means not a number, and this occur when we have empty cell. So here is also you can see in cholesterol, one value is missing at this place. So when this type of the problems are there, we have to handle this type of the missing values first. Then in the last column, we can have the disease. This is the target value. This is the target value on the basis of the parameters which we can see here, the age, blood pressure, cholesterol, BMI, okay, whether smoking or disease, yes, no. So on the basis of these parameters, we can predict, we can have the disease just like you can see, disease hurt and healthy. Okay, two types are there, whether it is a healthy or heart disease. So this is the target value on the basis of this parameter. So target value is output value on the basis of input. So age, gender, blood pressure, cholesterol, BMI, smoking, diabetes, these are independent variable. Okay. So how we can implement for the machine learning? This is our main question here. So these are the some basic libraries and the machine learning models you can see here, which are essential for this part. And one by one we will use them. So first one we will use here, just like a trend test spread to spread the data set. Then we have the label encoder, one hot encoder, standard scaler. Just like sometimes as we discussed yesterday, there is a huge variation in the values, so we can use scaler. For that, the values will be reduced to very small size. Okay, then level encoder, sometimes the values just like we can have male, female, or sometimes we have the qualitative data, just like good, bad, worst, okay, best. So all these we have to convert in some numerical data set. We have to assign label. That can be possible by using the label encoding. Okay. Similarly, we have the simple imputer, column transformer, pipeline, random forest classifier, etc. Okay. Random forest classifier is the machine learning model. Okay. And so one by one, all these we will discuss so that we can have some idea about these operations. As I told you yesterday that when we study about the methods and we apply for the real problem, both are very different. Okay, here we are required only the understanding, and behind all this we have some mathematical operations are there which we are not able to see here. Okay, so when we wanted to train the model, just we should have some basic understanding about all type of the models and what are the applications why we are using. Okay, so this will you will learn while doing some various examples. So here first I am required to start this shell control and enter so that all the libraries I can import here. Then we are taking here very small data set which you can see here. So this entire data set we convert by using dictionary in data frame. Okay, so these are the patient IDs, the same P001, P002, as you can see here, all these values. Then age, gender, and here is missing value. So how you can cite missing value? These are the numerical values of the age, and here this is the missing value, and p dot nan. Okay, nan is null value. Okay, so we can take, we can write, we can input by using numpy. Okay, so these are the age group. Then we have the gender, male, female, blood pressure we can have, cholesterol, you can see 220, 250, NP.9. This is also the missing value in cholesterol, 240, 230, etc. And these are the body mass index and smoking, you can see, and diabetes. And last column we have that this is the target value. Okay, output. So when you will execute this entire shell, you can have this data set. Okay, same which you can see here. These values you can see here. This is the index and these are the head of each column, and this value was missing, and in the cholesterol this value was missing. The same we have. After that, you can use explore data to understand the data set. We are very essential. So without understanding about the data set, what about the size, how many values are missing, what are the statistical descriptive static. Okay, and just like by using mean, median, mode, and maximum value, minimum value, this will help you to understand the range. Okay, then you can use data visualization, how the data is separate along x-axis, and how the height. So all these things will help you to understand the data set. And these are some few operations which we have apply here. So first is the info. So by using the info, we can have some basic information about the variables and the data size. Okay. And then we have the describe. By using the describe, we have descriptive values, and all these we have discussed already in the previous session. And then after we can have the is null dot sum. So here you can see the patient ID, age, gender. So in the age, there is one missing value is there. In the cholesterol also there is one missing value. So by using this one, if there are missing values, this will calculate and return the number of the missing values. Okay, by using this operation, which you can see here. And in the previous session also, we use the same function, df dot is null dot sum. Okay, so by using display, this output will be there in the file. You can see. Now, if there is any missing value, we have to handle the missing value. For that, we can have the way how we can do. So these are the numerical value you can see: age, blood pressure, cholesterol, BMI, then imputer. We are using a simple imputer. Okay, strategy we are using median. So at the place of median, we can use a standard deviation. We can use mean. We can use uh, here uh, other operations, just like uh, forward backward technique also you can use to for this imputer. So here median or mean is more, mode also is there, we can use. Okay, so according to your data set, data size, we can there is not a specific particular method which one is essential, but simply we can use mean, median, or mode we can use. Okay, if there is a various type of the frequency and are there, then according to that we can use mode. But if there is no frequency, means all the values are unique, just like for this model, this example, because the data set is very small. So for that, we can use only mean or median. Okay, and then the values which we store here, okay, impute.fit transform df num columns. Okay, so this will update the columns. Okay, numerical columns. And then again, when we will check by using the same operation, you will see that all the values now 0. Okay, it means there is no empty shell. If you want to print, then you can use here df. You can use df. Okay, previously I did not do, but right now we can do. So here there was one missing value of in age, and now you can see there is no missing value, and also in the cholesterol, one value was missing. But by using the median, you can see there is no any missing value. All the columns are complete now. That's why you can see these values are zero. Okay, so these are the some process how we can do, and these are very quite simple examples. Simple operations are there. Just you need to spend some time to understand the techniques and algos, because when you will train the model, there are many things which are new one, and time is required. Okay, if you say within one session or two session, you will be able to train the model and you are expert. Okay, so this is not possible. For that, we have to deep understanding about the concept, their applications, and operations, various operations which are required when you will complete 3 4 model project by doing this technique, and practice on it again and again by doing several experiment. Then after we can say yes, now you can have some knowledge to implement, to apply, to train the model. Okay, so we are required to spend some time on previously the part pre-processing, which include we have covered in the previous sessions. All those we can easily apply. But here the thing is we are going to train the model, and there are several techniques. We are not able to understand or directly to pick the technique and apply there and our model is ready. No, we have to test different techniques. Okay. And after getting the output, we have to test again whether the prediction is accurate or not according to our desire. Okay. What are the percentage? Sometimes the percentage is high. Still, our model is not well trained. For that, we are required to apply several tests. Okay, just like as we discussed yesterday. So that part is very, very essential and important. Okay. So here we have the encoded target value. So here you can see the target value in the last column. This is the disease. Okay. So to train the machine learning model, these values are not useful. We have to encode them. Okay. We have to apply some encode just like 0, 1, 2, 3. Okay. Because the index is starting from 0. But here we have only two categories, healthy or disease. So we have the label encoder, you can see, and we apply this label encoder for disease column. This is the variable. And on the right hand side, this is the label where we have stored the label encoder. Then fit underscore transform, this one. So what this will do, this will automatically transform these values in 0 and 1. Okay. Then one hot encode category feature is also required. PD.get underscore dummies. DF columns we have gender, smoke, and diabetes. Okay, we have the gender, male, female. Then we have the smoking, yes, no, and one is diabetes. So all those also we are required, one hot encode. And for that, improve first and true. So when we will execute, you can see control and enter. Okay, so we are using true first. Okay, so the new columns for gender, smoking, diabetes, you can see here, draw first, male, true first, smoking, yes, no, okay, true first, and diabetes also in true first. True first also can be understandable, and the computer can easily read because this is the logical value. Okay. So this is the one hot encode which are required. Whatever we have the disease, target value we are required and numeric, but other we can convert in one hot code. Okay. So after that, we have a standardized numerical feature. What is the meaning of this one? As yesterday, we talked about scalar. When there is a huge variation, okay, and large values, to reduce the complexity of computing, we can use minimum maximum function. And by using the same, the values are reduced to very small. Okay, just like you can see, here we are using scalar dot fit underscore transform for columns. What are these columns? Okay, see, age, this value, pressure, then we have the cholesterol. Okay, then we have BMI, body mass index. So these values are reduced into the very small size when you will execute control and enter. Okay, here you can see the values are now reduced in very small size. Okay, so when you will use this standardized numerical feature, or you want to scale the value, there is no impact on our output. Okay, so you can see all the values are reduced to in small size, and the other variables have the same value. After that, here is feature engineering. Okay, yesterday we talked about the feature engineering. Madam Renu Bala, madam, when we will apply training model, we will discuss right now. Okay. So first, we are talking about the feature engineering. What are these? Yesterday, also we talk about the feature engineering, and I give the uh, example of the if the age we are given from 10 to 90, we can divide the ages of the people or population in group. Okay, 10 to 20, then 20 to 30, 30 to 50, 50 onwards. Okay, and this is the feature engineering. Also, we can develop a group for the income. Okay, so low, median, high in this way. Here is body mass index. And here we are using if the weight is less than 18.5. If the weight is less than 18.5, then underweight, return underweight. If the weight is less than 25 but greater than 18.5, then normal. But if the weight is greater than 25, less than 30, this is overweight. This is the example because the data set have small data set and small values are there. So this is the example how we can use. As if the weight is greater than 30, that is obese. Okay. And if greater than less than 30, but less than 25. Sorry, greater than 25, but less than 30, overweight. Okay. So these are the categories, and by using these categories, we can divide the body mass index. Okay, this will be in the group format. And when you will create categorize in this way, so the complexity and accuracy increase. Complexity reduced, accuracy increased, and performance also. Overfitting not happen. Okay. Then we have we are using BMI. Using the original BMI should be preferred before scaling. And here we construct the approximate category of the demonstration. As you can see, BMI category is equal to PD dot cut. Okay, so the functions which we apply above, and on the basis of this operation, we will convert. Okay, this is the way how you can categorize. So here DF, this is the body mass, and bins we are taking from -10, minus 0.5, 0.5, 1.5, and 10. Okay, so this is the bins, and you know what are the bins. Okay, we discussed during the data visualization. Okay, this will create the group size. Then labels underweight, normal, overweight, and obese. Okay, so these are the groups. Then there may be some, just like blood pressure we have. Okay, the blood pressure is also there. Okay, so if hypertension, when the blood pressure is greater than 0.5, 1, and 0, these values. Okay, and high cholesterol for the same, and risk score we will take here: hypertension, high cholesterol, okay, and smoking, yes, age type integer. So on the basis when you will execute, you can have these outputs you can see here. So this is the hypertension, this is the high cholesterol, this is the risk score, okay, and these are the BMI category: normal, overweight, underfit, normal, normal, and all these values are computed by using this one, as we take the values which we have assigned at the page. Okay, so this is the new data set. These parameters are new one introduced in our data set, which was not given in our data set, but we create here. Okay, so this will help us for more accuracy. Just like this is the example. Trend, test, separate. How we can separate the data set? This is very, very important. So see, come back here. This is the target value. If there is a disease or healthy, okay, depend upon the parameters which we can see here, just like age, blood pressure, cholesterol. Okay, then we have hypertension, high cholesterol, and risk score on this basis, and also smoking, diabetes. Okay, we have to drop BMI category. Okay, this is notation. So here you can see this is, we have to drop because this is the target value. Okay, for the target value means output value. This will depend upon the other parameters. So we are not required as input argument. Okay, so we drop disease. What are the purpose of patient IDs? We have to drop because patient ID doesn't have any symptoms of the disease. These are only the symbol or ID assigned to the patient. Then BMI category. Okay. So where is the BMI category which we have developed here? This part: normal, overweight, underweight, etc. This is also not essential. So the values which are not essential to train the model, because when you are going to train the model or when you have some statistical analysis, we need only what? Numerical values. Okay, so non-numerical values we have to drop here. One is this column, then you can have patient IDs and disease. Can you please let me know, anyone, why we did not drop gender, smoking? Yes, diabetes? Yes. Anyone, please? Anyone? Why we do not drop these values? Gender, male, smoking, yes, diabetes, yes. Because these are the logical values and computer easily understand these. Python can understand this. Okay, whether you are using 1, 0 in the place of a true false, okay, or vice versa. No, there is no difference. Okay, so only unnecessary values which are not required, we have to drop from our data set. Okay, so here we are using these parameters we are not required, we drop by using drop function, df dot drop, and we store all the parameters in x variable. X is in uppercase because this variable contain all the parametric values in one variable, and y is the target variable, which is output value. Okay, so now our data is divided in two parts. One is x and other is y. One is independent and other is dependent. When you want to check, we can use here x dot head and control enter. You will see these variables. This is patient ID, BMI category are not there in now here. Okay, so patient ID is absent. This is also not there, and BMI category also not there. So this is one variable which you can see here. So all these values are stored inside X. And other is Y. If you want to check the Y values, Y dot head, you will use and check it. There is only one column. Name is disease. Name is disease. Okay, these are. Very interesting question. Kalpana. Kalpana, listen very careful. In our data set, there are various parameters. Okay. And there will be one output. There will be one output. Okay. If there is only one output, the other variables are input. Okay. On the basis of the input, we have output, which is the single value. So target value here is disease. This disease will happen or not depend upon the other parameters of the body. That is age, blood pressure, cholesterol, hypertension, high cholesterol, okay, risk values which we calculate here. Okay, risk score, what is the risk score? Smoking, yes, diabetes, yes. Okay, so these parameters. Okay, so these parameters will decide the person has disease or not. Okay, the disease, yes or no, will be in y variable. Okay, which will let us know whether the patient is healthy or having the disease. Then the other variables we are required on the basis of the other parameters will decide. Okay, these are the input arguments which we store inside x variable. Okay, so we have to separate the value y, which is the target value, and the input set. When you will map the graph for any function y is equal to fx, one side you have the x, which is the input, and on the right hand side you will have the output, which you will denote by y mathematically. That's why we have to separate the variable. One is x and other is y. X will contain all the parametric values. On the basis we will decide the target value, which is Y. So this is the separation of the data. But the main thing is do. Here you can see in the next level. We have to separate the data now. One is for the training purpose and other for is the testing purpose. So can you please let me know if you have studied about the ratio of separating the data set which we have discussed already yesterday? Anyone? So we have to choose the data set 80%, 80% for training the model and 20% to test the model. Okay, from the entire data set. And this is the statement, this is the code which you have to apply always in this way for all type of the models which you are using. To split the data set in two group. One group is to train the model and the other group to test the model. So here you can see here X train, X test, Y train, Y test. Okay. So X train corresponding Y train, X test corresponding Y test. Okay. And this is the function. You can see train underscore test underscore separate from scikit-learn library. Here is okay. Model underscore selection, import train underscore test underscore split. We are using this one to split the data in two groups. Come here. Yes. This part we have discussed. This also done here. This also done. This part. X train, X test, Y train, Y test is equal to train underscore test underscore separate X comma Y. X is the variable which contain all the independent variable. Okay, that's why X is also independent and Y is the target value. Test size we are using at 20%. Meaning of 0.2 is 20% data we are using for testing. And the remaining part will be for training. Random state is 42. And yesterday I told you that you can choose any value 1, 2, 3, 4 up to 100, any value which you need. You can choose any more than 100 up to 1000. You can choose any value 1000 to 10,000. Okay, doesn't matter. ये कोई मैटर नहीं करेगा. तो आप इनमें से कोई भी वैल्यू यू कैन चूज एनी वैल्यू यू कैन एंड मोस्टली वी आर यूजिंग random state 42. There is some reason, but I don't have the right example. Okay, so there was some one scientist was there, and this value becomes familiar because of that scientist. Okay, so here you can take 41, 42, 43, 45, any value. The difference, there will be no difference. So this is the way how you can use, and after that you will print the x train dot shape and x test dot shape. One is train and other is test. Okay, so what is the meaning of a train and test? Shape. Shape will determine the size. So when you will execute, you will see we have only the 5 values and 4 values are taken to train the model, and 1 value is taken for testing the model. Okay, so and 10 is equal in both the group, because these are the column. We do not change the column. Okay. The data will be split according to the entries. Entries means number of the rows. Okay. So this is the way how you can separate the data for training and testing. One example. Then we have the pipeline. Okay. So actually, what is the meaning of pipeline and how we can use it? So to clear the concept of the pipeline, we can have pipeline, actually the sequence of the data pre-processing and the machine learning steps that are executed automatically in the correct order when you will apply pipelines. And these help us to organize the workflow, prevent data leakage, and makes our code cleaner, reusable, and easier to maintain. Okay, so the steps which you can see here, first is the raw data. So here we are taking the example of the pipeline. Numerical feature and categorical feature are there. Uh, Age, blood pressure, and cholesterol, BMI. These are the numerical feature. The values inside we have is numerical value. Gender, smoking, and diabetes. These variable contain categorical data. As you can see here, come to the top. Gender, smoking, diabetes, disease. This is also converted into scale. So these are non-numerical values. Okay. So here you can see yes, gender, smoking, and diabetes. Okay. So these are what happened to my mouse. Okay. The file freeze. Okay, you can see here gender, smoking, and diabetes. So there are two type of the features of the data. Okay, numerical and categorical. So here, oh, sorry, my file freeze, no action. So here you can see the data in two categories. One is the raw data. Okay, so we will recreate the original data frame for the pipeline demonstration. As you can see here, raw, age, gender, blood pressure, cholesterol, BMI, and the target value. The another is target, which is the disease. For disease, we are taking here 11010. Okay, and then we have the numeric transform, and we have to apply here. Okay, so for that, to fill the we use two type of the operation because values are missing. Okay, in two column values are missing, so we have to fill them by using median, just like we do in the previous, but right now here also we are doing by using the strategy median. Okay, you can choose main or mode, STD, or any other, but mostly we are using just like main or median. Okay, or sometime we can use mode and scalar to reduce the size of the value. Okay, so these are the numerical transform, and here is the categorical transform. Okay, so here imputer, a simple imputer we are using for most frequent, and one hot we are using drop first. One hot encoder drop first. Okay, and then we have the preprocessor column transformer. Okay, so we have these two type, and both are, you can see, when we have the column transformer, so numeric transformer and numeric features both will be in numeric, and categorical, which we have used here, this one. Okay, so categorical transformer and categorical features both, okay, which we have done here. And then after, you can see pipeline, preprocessor and classifier, both are there. And after that, pipeline dot fit raw and target. When you will execute, this will be successfully, all the operations has been done, and this is the print, pipeline created and model trained successfully. Okay, so the training part has been successfully for this one. Okay, but actual algorithm we have to implement. Okay, so that we will implement the remaining part up to how we can do the prediction. So in the coming session by tomorrow, uh, I will prepare one complete model, okay, which will have the prediction, all type of the operations, and then after we will compare them. So till date and till model, whatever we have studied, all these I will not repeat them. We will come to the directly on the model and model evaluation. So the last part is only how we can apply the various models which we discussed in the yesterday's lecture, and in the coming session we will implement them for the prediction, and then along with we will discuss about uh, their testing part. Okay, model evaluation. So these two part we will cover in the coming session by tomorrow. Okay, so and this is all about for the today's session. Is there any question you can ask from me? Dear participant, any question? You can unmute your mic. Good. Okay. Kalpana, I think you got your answer. We have 30 minutes more. Actually, I wanted to use the same data set which we discussed in the previous session. So that if I have the different models, but the problem will be that if the data will be new one, you will be confused. So that I want to use the same data set which I used in the previous session. Okay, all type of things we have complete. But for the training and the prediction test modeling, this part are required to update in the same file. That's why I wanted to close the today's session at this place, and in the coming session we can easily do. And along with if you have some question or you want to do more about for your help or you need, so you can ask from me. We can discuss because we have 30 minutes. So during this 30 minutes, we can discuss many things.
So, sir, we have to prepare models with different algorithms, I think, yeah?
Ranjit?
Hello?
Yeah.
So
Dr. SS. Yes, yes.
we are using random forest here. We can use logistic regression also, or linear regression, right?
Sir, actually, the thing is when we applying, Actually, the data is categorical, or we want to apply for feature extraction or prediction. Okay, so various models, some type we have to test which model will return accurate value.
Yes.
Okay, so only by using the single model, we are
Mhm.
not able to decide this model is perfect for this data set. So two or three models we are required to apply, and
Exactly.
we will check. We will compare them. Which model
Yes.
have the more accuracy?
Yes. Yes.
Okay, according to that we will decide.
Mhm.
Okay,
Okay.
in the coming session, I will try. I will introduce this type of the prompt. Two or three or four model I will introduce, and we will compare them.
So
Okay, so
evaluation
which,
also will do. Model
pardon?
evaluation also will do.
Yes. For the same problem, we will use two or three model. Okay, we can use four model. Okay, but must be applicable. And
Okay.
then we will check the accuracy, which model produce the more accuracy, because this is the part of the experiment.
Yes.
And this is also the very crucial part. Okay, so if we are trying only one model for the same, maybe the another model can produce more accurate value. Okay, so the comparison and the existing model we should try so that we can have more accurate prediction. And our main target is to reduce the error in the actual and the prediction model, predicted value. Okay, so as much we have the small error, we have good model. Okay,
Yeah,
what
we
we
have
do? Yes, please.
the highest accuracy model we'll have to select.
Pardon?
The model which is having highest accuracy, suppose we are having 80% and some model is
Yeah,
having 75,
actually,
75%.
this is not the fixed ratio. Actually, uh, if we talk generally, the more data we are required to train the model. As much you have the more data, we have more accuracy.
Yes, yes,
Okay,
correct.
and for the testing, we need only very less data. So the range which are we are given, at least 70% data we can use for the training, and 30% will be for testing. If you are choosing 80% for the training, the remaining 20% will be used for testing. If you are using for the 90% for the training, then left we have is the 10% will be for testing. Okay, but
That I understand, sir.
generally,
I'm
yeah,
talking about
generally
this.
we are using 80%.
I'm talking about model accuracy, sir.
Pardon?
I'm talking about model accuracy. In some cases, we may get 84, 85% accuracy. In some, suppose 70, 75%. Then we have to select the best accurate model.
Yes. Actually, if the model give us 70% accuracy, that is very low. Okay, so we are required to increase the model accuracy, and there are many things. Just like if you have size of the data is small, okay, and on the basis of the small data set, you want to develop a model for the prediction. Naturally, the accuracy will be less. We have to increase the size of the data set. Number one. Okay, so the size of the data set is also matter. Actually, we should at least if you have only the 1000 data set to train the model, this is very small. If you have 10,000, yes, it can increase the accuracy. Okay, but if 1000 giving us the accuracy about 70%, then 10,000 we can have 75 or 80%, but we need
Yes,
the accuracy more than 90, more than 95, more than 99. Then we are required the size of the data set 50,000, more than 50,000. Okay, this is the
exactly.
one part. If we have the data set very large, just like 50,000, and we are testing, and we found that the accuracy is by using one model it is giving 90%. By the another model, this is giving by just like 95%. And there is one more model which is giving us like 98%. Okay, still then we can increase the accuracy by using feature scaling, which we discuss. This is also the most important part. So we actually, the most important thing is as much you will understand your data, you have good planning. Okay, planning to implement the feature engineering, that will also depend upon the problem, what you can do with your data set. Okay, because as we discussed now, feature yesterday also, feature engineering help us to reduce overfitting. It help us to reduce the complexity. It also reduce the computing process, reduce the timing. Okay, and take the less time to produce the output, more accuracy, high accuracy produce. If we will implement feature engineering, and that is again depend upon how we are using. Okay, so
Yes.
all these operations which you will apply are really benefited to improve the accuracy of the finding. And now after applying all these, and you have three models, again when you will apply, the accuracy of these three model will increase. One can have 90, another have more than 96, 97, and the last one can have 99% plus. Okay, so
Yes.
we have to find how much we can increase the accuracy. Then we will compare. And one more thing, if we have the accuracy is 99, more than 99%, still we are not to say that the model is more perfect. We have to test the evaluation, the accuracy which is produced by the model must be tested. So there are several parameters. Okay, sometimes we are using the three model and one model having the accuracy more than 99%, but when we will test the model, okay, so the evaluation, in the case of the evaluation part, the model fail. Okay, so this is very crucial part, and here we need very deep understanding what type of the test we can implement, what are the ways how we can test this model, whether the predictions are very high, but still then we need to apply test to check the whether the outputs which are getting the findings which we have are really valid or not. So validation of the model is very essential after training the model. Okay, so
Yes.
this part without testing, we are not able to deploy the model, which we discussed yesterday in the last. Okay, so there are some parameters, there are some tests which we are required to perform, and we do. Okay, don't worry about that. But when you will be familiar about the information, only the test accuracy is not sufficient. If we are not test the validation of the model, okay, and then what type of the techniques are there to validate the model, and all these we have to justify, we have to compare all the features. Then if all these meets the requirement, then we can say our model is fit to deploy. Okay, so all the status we are required to complete and we are required to test. Then we deploy the model for public user. Okay, so any more question, please? Are you justified,
Thanks.
sir?
Yes,
Professor
sir.
SS, yeah. Sir, are you from which place?
I'm from Guwahati University,
Which one?
Assam. Assam, Guwahati University.
Guwahati. Okay, okay. SRM.
Guwahati University, Assam, Assam,
Guwahati. Okay, okay,
Assam.
Assam. Okay, great, sir.
Yeah.
Great.
I'm,
So
I'm a
any
faculty in the
more
Department of
question?
Biotechnology.
Pardon, sir?
I'm a faculty in the Department of Biotechnology. Basically, I'm uh, doing with this biomedical data as well as chemical data also. Generally,
Oh, great,
I
sir. Great.
learned
Really,
some.
there are so many applications. Yeah, you are doing well, sir. Actually, there is one subject in the biotechnology, bioinformatics.
Yes, yes.
Okay, so we can apply all these techniques, deep learning concept.
Yes, yes, yes.
Okay, so you are using machine learning or deep learning is also there?
No, I'm learning. I'm planning to
Okay,
apply. I'm
okay, okay.
learning now.
Okay, good, sir. Good, good. Okay, so one more thing I would like to add here. You must try to cover some statistical concept, which are
Yes, yes.
essential. We are not required to cover everything in state, but the essential part which we need. Okay, so the roadmap which I will share yesterday and the presentation which are just specifically artificial neural network. Okay, so ANN we are required to cover, DNA, RNA, sorry, CNN is also there, RNA is also there. So these are three which we can use for the deep learning and will help us to develop a model and some mathematics is also required, just like
Yes.
derivative, partial derivative, calculus. Okay, so this part is also required for uh, deep learning. Okay, and for the machine learning, only the linear algebra and along with some statistical methods which are required, which we have discussed, are sufficient. But if you are interested to work on deep learning, then we should have understanding about the derivative, partial derivative, gradient, etc. And because all these are applicable there. So when we will talk
Yes.
about, you should, I request to all the participants, I will share with you one book. Okay, maybe some typical for you to read out, but mathematicians having the good mathematical background, they can easily read this book. Okay, I will share with you after the session. This is the one of the best book if you want really to work on AI. Okay, because
Okay,
all
sir.
the fundamentals which are required for deep learning, just like ANN, then CNN, RNA, all these are clearly defined. And most important thing is Python examples are there, which you can implement, you can use them, uh, but not complete the book only within 1 month. Spend at least 6 months to complete the book continuously.
Okay, sir. Oh,
Okay, 6 months is required for deep understanding. And after covering that particular book, you will have good knowledge about this area. And you will share in the coming days. You will train in the coming days for the new generation in your domain. Okay. So, as I am mathematician, I can work in mathematics and mathematical applications. But if I want to work in biotechnology or a biomedical field, then I need to cover the medical background. I should have the medical background also. Okay. So sometimes these things are not possible. But
yeah, it
as
is
you
possible,
are
sir. We
biological
need to
background,
if we have
yes, sir.
collaboration, we
Yeah, collaborations
can
are also important. We can collaborate in various way, and actually in India we lack in the collaboration. And I will
yes,
say now very truth because we don't
yes,
trust on the other people. This is the truth. Okay. So we are not sincere. We always hide, and we are always in the race. So this is the problem in India. Okay. So we sincerely collaborate with each other. First, help the people. Okay, if anyone wanted to collaborate with me, I will help you. But sometimes the thing I saw many examples and in my groups also. So if we want to get some information and after that we manipulate everything according to our choice. So these things are not good. Okay, and these things are happening. There is one my student, Avinita Gautam. She is now in Germany, working in drug design company. Okay, so
Yes.
I asked few days back because it is about during 2016 she started the PhD, and after that getting some information which she need for her research, and after that after completing her PhD from IIT BHU, she is now in Germany for 1 year she spent for postdoc, and now she is in the company. And a few days back I got email, and then after I get WhatsApp, and some discussion was there. I asked a very simple question. Actually, she has the background biomathematics, and
Okay.
she is working in a drug design company. So
Mm.
I asked one question, Avnita Gautam, please let me know you are working in this company and how you are working there. She told me about the scenario where she is working. Sir, we are in the team, and in the team there is MBBS doctor, there is a
Yes.
mathematics specialist, as she Dr. Amita herself, and one is a statistician expert, one is computer expert, and one is from one more person there was. So there were 5 persons in the team, but the same thing in our Indian lab where exist. Can we see this type of the lab in our country?
No, we're lacking in collaboration. Collaborative work.
So this is the problem. Recently, my colleague, Mr. Dr. Uttam, and he worked on cancer. Okay,
Yeah.
and he told me that he is also from BSU and worked with
Oh,
me for 2 years in my institute in at Bathinda. Okay, he told me that his supervisor told that don't go to the biotechnology lab, they will not help us. Okay, so if
mm.
in such institute these things are there,
Yes.
then how we can collaborate? First thing, we need mindset, what we want. First thing is, I think, according to my opinion, we should contribute first for the country. If we are working for the country, I think everything which we will contribute to one day, we have everything which we need. Okay, if we will not help to the people, then how we can expect to get the help from the people? Okay, so first we think to give the help, and then after we
Yes.
can expect help from the other people. And this is happening. There are many people who are working, there are who are helping me without any boundaries. Okay, so I never expected without helping the people, people will help me. So if we work in this direction, I openly discuss today in this session because we have time. We have time. Okay, we should discuss
Yes.
this part. Okay, we should sincerely work together. First, we should try to help the people. If there is any barrier, we should help. And without any boundary and without any expectation, I always try to help the people. And one day they come together to me to help me, and they are doing. So sometimes, if one is working on the project, that is his part. Okay, if there is some problem, we should help. Okay, anyone, we should help if we can do. Okay, so that he can contribute. If he or she will complete the project, ultimately she or he is contributing for the country, for the society, okay, and for the all the community of that domain. So we should bridge to help the people. And one day also, when we need, automatically we have the way, the peoples will be there who will come to help you. So we must collaborate, to collaborate to the help first. How we can help that the one who is working in a specific domain and he can complete without wastage of time. Okay, and time is very important for everyone. So if still you have any question, I speak a lot of things, but I wanted to know your views also. What do you think?
So now the thing is that AI and ML is everywhere, sir. It
Yeah.
be biotechnology, it
Yes,
be
yes, yes.
chemistry, it be medical
Mm.
data analysis.
Mm-hmm.
So I'm trying to work in two directions. One
Mm-hmm.
is chemical computing, and another is biomedical data analysis.
Mm.
So I'm trying to learn. That's why I'm trying to learn this. I have attended some workshops also earlier, but I was not satisfied with those workshops.
Mm. Good thing, sir. Actually,
This
yes, yes. Yeah.
in case of chemist, this chemical computing, that means application of AI ML in that means compound property prediction. We
Mm.
have that line is there. You
Mm-hmm.
have to build a model, and then you have to put the compound information, and then it will predict it whether it is going to be active or it is going to have effect in case of a particular
Mm.
disease or not. That kind of prediction is there in case of chemical
Mm.
computing. So we
Yes,
have
yes,
these
yes.
two directions. One is biomedical data, and then another is chemical
Mm.
computing. Uh,
Mm-hmm.
Property prediction by building the model, and then you have to take the known compounds and then their properties and then fit in the model, and then build a model, evaluate it, and then you have to and then test it with this. You have to split that. You have told 80/20, and then again you have to test it like that.
Okay.
So that I'm trying to learn, and then trying to implement in
Yes,
case
yes.
of chemical
Still, if
computing.
sir, if during your work, after the workshop, if you need any help, okay,
Okay,
no, anyone having the help, required help from our side. Okay, so please don't
okay,
hesitate. You can contact us anytime. Okay, so we are here to help you. If there is any challenge where you are facing some problem or you need some idea how you can implement, okay, I am saying to all the participants, whenever you need, because you have now good idea, but the time was very less because 7 days are not enough time. Okay, there is one other workshop is also going. Okay, that was 45 days. Okay, 45 days is
Mhm.
also very long time, but they clear the
Long
concept,
time.
everything because time is very enough. So the same thing we are completing within the 7 days. So many things you have the ideas. Okay, you can start your journey. And also, if you need one more session, I want to take. If you will permit me, I will take your one more session. Okay, tomorrow is last day, but I would like one more session only for how you can sort out the problems if you want to do everything yourself. Okay, that is necessary. So I will uh, demonstrate the example to integrate generative AI, which help you to learn many things which you want to implement. Okay, now you
Okay.
have many ideas, but sometimes if you have any challenge, just like yesterday, I don't know whether I let you know how to interpret the outputs to get after getting the uh, applying any testing operation. Okay, you have the some output, but we are not able to interpret in the very beginning. So in that case also we can integrate. And the other part, when you need to find out the solution, and you don't know what should we do now. Okay, you don't have the idea. Okay, so then there is also collaboratory Google Colab, which I want to demonstrate, which is completely based on generative AI, and this is the solution of Google. Okay, Google developed the Colab, and we say
Yes, sir.
collaboratory. So there is many options from where you can get some ideas and you can implement, you can try there. Okay, but how you can use that? I will demonstrate one example if you will permit one day more. Okay,
Exactly, sir.
yeah. And
That's fine, sir.
how you can use generative AI tools if you are doing some experiment to develop some model, but you have some challenge. Okay, so that also you can integrate, and I will demonstrate. So during one session, you will have lot of information, and in the future, I think you don't have any problem if you will adopt these techniques, which I will demonstrate in the new one more session. Okay. So
Thank
any
you.
more?
Thank you.
Yes, thank you, sir. Any more question from the other participant? Renu madam, Kalpana madam, Ritu Arora. Ritu Arora madam, I think you are from Punjab, if I am correct. Ritu ma'am, Dr. Ritu, are you there? Okay. So dear participant, if there is any more question, otherwise we can conclude. Okay, I think there is no more question. Dear Faiz, we can conclude the session. And the file which I present now, I am going to share with you in the group. Okay.
As we conclude today's session, I would like to extend my sincere gratitude to Dr. Meher Chand for delivering an enlightening and highly engaging lecture on AI applications and generative AI. I encourage everyone to continue experimenting with AI tools, refine your prompt writing skills, and use these technologies responsibly to enhance your learning, productivity, and problem-solving abilities. As generative AI continues to evolve, staying curious and practicing regularly will help you make the most of its potential. I'd also like to sincerely thank all participants for your active participation, insightful discussions, and enthusiasm throughout this workshop. Your commitment to learning has made every session interactive, engaging, and truly rewarding. Thank you all for being a part of today's session. Have a wonderful night, and we wish you continued success in your journey through artificial intelligence, machine learning, and data science.
Thanks, dear participant, and good night. File I have shared in the WhatsApp group.
Thank you, sir. Good night.
Thank you to